Yeah, I love doing math. You love doing math. We love doing math.
Hey math lovers, let's go over quiz number 1. Consider the following scenario, then select the best sampling method for this scenario. When every member of the accessible population has an equal chance of being selected to participate in the study, the answer is simple random sampling. Everyone has an equal chance. Okay, what are the other ones? Stratified is another word for like groups. So let's just say I put all of the 9th graders. These are my people, my stick figures. You like them? And then I have 10th graders. And then I have 11th graders. Now they don't even have arms. And the 12th graders. And let's just say I need a representative from each group. And I just randomly select, right? That would be stratified. Systematic, let's draw over here. This one would just be, you know, if I had a bunch of people. Maybe just line up all the students in school, and then I would select every third. Does that make sense? So there's some kind of system in play. Okay, for clusters, I hope you guys appreciate my drawing skills, okay? You have different rooms, so I'm in room 902, then my neighbor, of course, is 901, and room 900, right? And each of these rooms, there's a bunch of students in there. And so they're already naturally in clusters. And in clusters, it's not about the individual. It's just whoever's in that room. So if I randomly select a room, like my room, they're not sure if they're going to have 9th graders, 10th graders. They're just going to pick everybody in here and interview them. Okay? All right, let's try the next question. A researcher who wanted to determine the benefits of using new algebra study technique. I don't know. Think of it like, you know, kung fu, mixed martial arts move, but in math. Obtained permission from the school district to select 50 high school students. The researcher selected 50 algebra students at random. The researcher selected 25 of these to participate in the new program. So I'm just going to draw myself a mapping. I got 50 algebra students, and then they're saying from this group, 25 of these are in this new kung fu math. The researchers gave a training session on the traditional, so 25 in the old ways, and asked them to use these methods. The most likely target population, so again, population is who we focusing in all in this study is it just the algebra students in this study? Is that what the population, another word for population is like all or big, the biggest group possible? Nah, it's not that. All students in the district? No, because they're focusing on what is this new Kung Fu algebra math. It has to be math related. It's not just every student. So the answer is all algebra students. Question number 3. Identify if the sample is biased or non-biased for sample questions. Remember the word non-biased. Whoops. I would just say you're in the middle. And a biased kind of means you sway one way. Right? Today I'm kind of biased because the shirt I'm wearing is a Hawaiian shirt with flowers on it. So I'm kind of biased towards talking to people who are wearing other Hawaiian shirts. But if I was non-biased, I would just, I would talk to everybody, all the teachers. Okay, let's talk about Nancy here. Nancy, down here, questioned 21 students who were all in the same introductory math class at her college. So So maybe Nancy is being paid by the college to figure out how do the students like the cafeteria food, and she's like, you know what? I'm just going to jump into one class. Maybe she didn't. She just jumped into the nearest classroom to her. Well, this sounds kind of biased, because it doesn't tell us if she randomly picked that classroom. This could be like convenience sampling. You're just trying to get it done, you know? Okay, in the dark, Jaime, or Jamie, picked out t-shirts from her closet. Okay, sounds kind of weird, but what does it mean to be in the dark? You can't see. What does that mean? So you're not actually looking at the different types of shirts. Maybe it's colored, or if it's a long sleeve or a short sleeve. That means each shirt has an equal chance. Does that make sense? And then therefore this one would be not biased. Alright, question number 4. You design and give a survey to your homeroom class. The survey includes the question, to the nearest half hour, how many minutes do you exercise each day? Suppose a national gym franchise decided to calculate the number of minutes teenagers exercise each week by using the results of your class. What is the population for this problem? Remember, we're trying to think of who is the all or the biggest. And here, they came and gave this survey to your homeroom class. But is this the goal of what they're trying to do here? Well, let's think about this. This is the hard part about statistics. We have to read into it a little bit. Well, what is this national gym franchise? I don't know. 24-Hour Fitness, LA Fitness, Gold's Gym. What are they trying to do here? They're trying to, figure out if teenagers actually go to the gym, right? They're trying to calculate the number of minutes teenagers exercise for each week. Now, they're just focusing on your class, but the whole goal is these teenagers. Is it just teenagers in your homeroom class? No. Is it just teenagers who exercise? Well, it is a national franchise. So, you like McDonald's everywhere? Well, I want Mr. Ng's math building gym everywhere in every street, right? So you're thinking about teenagers across the country. So your answer in this one would be C. Okay, question number 5. Let's just number these. Match the statistical terms with their definitions. 1, 2, 3, 4, 5, 6. Okay. Where do I think statistics is? Well, statistics is the study of, right there, collecting, organizing, summarizing, analyzing, and drawing conclusions from data. Okay, what is a variable? In algebra, it's like an unknown, but in statistics, a variable is kind of like a characteristic, right? A characteristic of all the teenagers are coming to school these days. They are wearing, you guys are now wearing like baggy, open-ended, I'm going to show my socks, right? Okay, number 3. This is just the biggest group possible, so that would be all subjects being studied. And what do we got next? Number 4 is a sample. A sample is a group of subjects being studied. All right. Descriptive statistics, you're describing, right? So that would be describing a situation here. And then the last one, number 6, inferential means to infer or to generalize from samples to populations. All right, question number 6. Each of these data sets has a mean of 20. So you have 3 sets here with different numbers. Order the sets from greatest standard deviation to the least standard deviation. Okay, so what you can do is use your graphing calc 83, a graphing calculator, or you can do this by hand. I would not want to do it by hand because I have the technology, because it doesn't say we can or cannot. So graph and calc 83, and I'm on the home screen, press clear, and then I'm going to go stat, edit, and have my list up here, so I'm just going to clear those. Clear, then enter is what I'm doing. Okay, list 1 is going to be set number 1, so 18, 19, 20, 21, 22. Okay, so list 2, they're all 20s. And we'll talk about the conceptual when we go through finish the problem. And then the third set has 16, 18, 20, 21, and 25. Enter. Okay? So now I have all 3 sets in set 1 in list 1, set 2 in list 2, and set 3 in list 3. So now I'm going to go out of here. So I'm going to press second mode. I'm going to press stat, calculate, 1 var stats, and I'm going to press now second, and then the number 1, because that'll give me list 1. And right there I'm looking for the population standard deviation, which looks like OX, but that is actually a sigma. That's what the Greek letter is, but it looks like OX there on the left column. 1, 2, 3, 4, the 5th one down. 1.41 is our, for that one. Let me write that down. So we have standard deviation of 1.41. Okay, let's go to the other one. Okay, stat, calc, 1 var stats, and then you need to tell you where you're getting your list from. Another way to get L2 is just pressing second, stat, and then the names of the list are there. So I can just press L2, and then, ooh, look at my standard deviation there for the population is 0. We'll talk about that in a second. Okay, and then the last one, same thing. Stat, calc, 1 var stats, second, 3 gives me L3. And press enter, and then 3.03. Okay, so which one has the greatest? That would be set 3. And then the least would be, or the smallest would be set 2 in orange there, and then pink, set 1. And I want to show you guys kind of graphically what's happening. You know, if you did something called a dot plot, and this is, I have the numbers 15, 20, 25, and 30. Okay, and I graph these, so I have 16, 18, 20, 21, and 25. What do you notice about those numbers? They are what? Like the jam, they are spread out. So they have a great spread. Great spread is like a big spread, which means that number is big. That's why it had the greatest standard deviation. Standard deviation is a measure of spread. Let's do the same thing for the pink one. Here's 15, 20. I'm just making a really quick number line here. And I have 18, 19, 20, 21, and 22. Okay, so those numbers are not as spread out as the blue jam. This red jam, I don't know, raspberries, not too far, right? It's staying in here. It's not too much. Kind of, you just plop it on the bread. Does that make sense? So this one I would say has small spread, or little spread, or little variation. Okay, but let's look at this orange one here. 15, 20, 25, and 30, and all the numbers are what? It's kind of like, well, one of my kids kind of does this. They can stack up all of the Skittles. They can stack up all the spread in one place. So there is no spread, right? There is no variation. It's not being moved out, so no spread. No spread means your standard deviation was what? What did we calculate it to be? 0. And I think that's the end of the quiz. We'll see you guys later. Bye.
Now that you're interested in math, you should go follow David Eng in YouTube. He's really smart and really funny.